Now let's continue on with our BGP verification. So in the last section, I was having issues with that my set fact operation was not working properly. That basically each time through my with dictionary, I was getting a new variable here. Now notice the problem that I have. This BGP current neighbors, I actually misspelled neighbors. So this needs to match what I'm setting here. So this variable here needs to be spelled properly and look like that. So basically, each time through the loop, this gets set. In the case when there's no variable here, and then it just basically gets reused and it appends this item onto it. In the case when there is no current BGP neighbors, then we set it to the default list. Now let's go ahead and rerun our playbook and see if it looks like we are not properly creating a list of our neighbors. So we're going through gathering our show information. I need to run this with the VVV, so in verbose mode. We're going through gathering our show information again. Now here in a minute, we're going to be constructing our list of our current neighbors. Okay, so here's our current neighbors for PyNet router 1, and we now have 3 current neighbors. And that's correct. We have PyNet switch 5, PyNet switch 6, and this iOS XR router at 88. Here's our current neighbors. That's PyNet router 1 going through a different loop iteration. Here's our current neighbors for PyNet switch 6, and then here's our current neighbors for PyNet router switch 5. Okay, so now it looks like we have that working correctly. I'm going to go ahead and get rid of the testing napalm connectivity. Okay, so now, and I'll go ahead and get rid of this, which was me looking at the data structure format. So now what I want to do is compare my current neighbors, the ones I'm getting from my show command, to what I configured in my host variables, to what I configured here. So I want to compare what I configured to what's currently showing. So now let me copy in this data structure from my inventory. So now I actually need to construct a proper list here as well of my intended neighbors. So I'll do set fact, and I'll call this BGP intended. So these are going to be my intended neighbors. Now look at this data structure I have here, and I'll actually look at it on router 1 because it's a little bit more meaningful there since there's more than one. But BGP peers is a list, and it has multiple elements. In one of the elements, each of the elements returns a dictionary. In each of those dictionaries, I want to grab this peer IP. Now there's a way you can do that using your Jinja 2 filters, and we talked about it earlier in the class, but it's basically this. I'm going to copy this data structure in a more fuller format. We'll basically do set BGP, set fact BGP intended. We'll call this BGP intended here. We will, actually I don't need, do I need to do that? 1 second. I'm just trying to figure out how to process that list. So I have my BGP peers variable. So what I'm going to do is I'm going to loop over BGP peers. Well, not loop over it. I'm going to process it. I'm going to use the map filter. I'm going to want the attribute equal peer underscore IP. I'm going to cast that in to a list. Now let me comment out this 24 through 30. Let me just make sure that that works properly. Okay, so let's add a name. Call it intended neighbors. Get rid of our extra hyphen. Go ahead and run this and see what happens. Once again, running it with the -VVV option. And we're only really concerned about the very end here. Okay, so I messed up something in the map syntax. Let me look at the map syntax that I used here. It needs to be attribute, not attrib. So we'll go here. Let's try that. Attribute. Okay, let's try to run that one again. Once again, it's going to take a while to get down to the point we care about. So here's our intended for switch 6. Here's our intended for router 1. Here's our intended for switch 5. Go back to our validate. Look at this. What am I doing here? I am taking this data structure from our inventory, BGP peers. I'm processing it with the map filter. I'm only going to grab from the map filter this one key, and I'm going to convert it to a list. So what basically this map with list does is it goes through each of these dictionaries in this BGP peers, and it only extracts this peer IP attribute, and it returns a list of all those values. So that's exactly what I want in this case. So now when I get to line 22, I have two variables. I have a BGP current neighbors, which I retrieve from a show commands, and I have a BGP intended, which I retrieve from our inventory information. If everything is correct at this point, these should exactly match. If it is not correct, they will be different. So now we need to write some sort of a test that checks that. And here I'm going to say name verify BGP neighbors. I am going to say do an assertion test. Assertion module has an argument called that. And here's our assertion criteria. We are going to say that BGP peers has to match, and we're going to do a symmetric difference. So let me pull up this, pull up a window. I'll do a Google search on Ansible, symmetric difference. Go to the filter. I'm just looking for the syntax for that. I'll do a search. Okay, so here's the syntax that we're going to use. So remember, a symmetric difference basically will say these two sets should be the same. So it's going to do a set comparison and see if set 1 exactly matches set 2. If they exactly match, this will come back as being empty. Okay, so we're going to compare BGP current neighbors to BGP intended. And actually right now, and I'm actually going to cast this as a list at the end. And I'm going to actually wrap this here. And I'm going to actually first start with just a debugging statement because that is easier to validate. So we'll make this be debug. And we'll make this be message. All right, so let's just look at what we get for our message. Didn't like that syntax. Oh, I had an extra space here. It wasn't aligned properly. Rerun our playbook. Have to get to the complete end of our playbook. Okay, so we look at that symmetrics comparison. So comes back as an empty list for switch 5. Comes back with router 1. There's an extra peer. This is the result of the symmetric differences. So this is basically saying that one side had 88.38 and the other side didn't. Now we know from inspecting it previously that this iOS XR is actually showing up in our operating in our show command output. And then here's the PyNet switch 6, which it comes back as an empty list. So now the last thing we need to do is convert this into an assert statement. Get rid of our debugging. And we will test if that works. I'm going to copy BGP validate to BGP validate .orig. I'm going to go ahead and get rid of everything else that's in here. So our entire playbook is this. Run our playbook and see what happens. Okay, so performing the show commands. This is actually incorrect at the top name. This should say that should have said verify as opposed to configure. Okay, so now we're failing. So now let's go ahead and fix this, which is verify BGP. Now let's go back and look at what went wrong here. So it didn't like this. Let's get rid of that list conversion and see if we don't need that. Go ahead and rerun our playbook. Gathering our show information again. Okay, so now I see my problem. So I need a conditional check in here, and I don't really have the proper conditional check. The conditional check I need is this should say equals equals blank list. So if this all comes back as a blank list, then we're correct. If it doesn't come back as a blank list, then it's not correct. So let's go ahead and execute that. And actually, let me run it for comparisons on one I know is going to work. So let's just run it on PyNet, or should work, which is PyNet switch 5. So it should pass for PyNet switch 5. So it verified our assertion was correct. And now let's run it for PyNet router 1, where it should fail. Here we got it, and then it says our comparison was, is this list, the one that contains the iOS XR router, empty? And it's not, so that assertion fails. Now I know that this was really complicated and really challenging. So let's step back and just review at a high level what we did, some options for how you could try to solve this, and some tools you can potentially add to try to help you in the long run. So the first task is pretty straightforward. We're just calling the Napalm get facts module, and we're using our BGP neighbors filter. If that doesn't make sense to you, review the class on Napalm. We talked about this in quite a bit of detail. Now, I look at this output. I see what I get back there, and I work out that I need to strip things from that data structure. So I peel back the key global because I want the global VRF. I peel back the peers key, and I just do a debugging statement to simplify it. I then actually take that debugging statement and I use it, well, I use the equivalent string, the equivalent processing, to create a new variable, BGP operational neighbors. I create that variable at this point. Now I need to somehow simplify our data structure, and if you remember in the earlier class, I gave you some tools for how to simplify your data structure. One of those tools is to use Ansible looping structure. So here I used with dictionary, and I used a looping structure to create a new list from this list or from this data structure. If you remember earlier, there was another tool I gave you in a toolbox, which was to use an external lookup, pipe it through external Jinja2, and read that output back in as YAML, as a new YAML data structure. That's a totally valid alternate solution. A third solution you could use, which I haven't really talked about, is you can use custom Jinja2 filters, and you can write them in Python and use that custom filter to do your conversion as well. So that could be a third option you could potentially use. But at the end of this, we have our current BGP neighbors as a list. We go down to line 20. In line 20, we actually need to get what we intended. We need to get that in a simpler data structure. Once again, we have different options available to us. We have basically the same options as we had in this step at line 16. In this case, there's a pretty simple conversion we could do. We can just do this map, which takes an attribute. An attribute is a key, in that data structure we have, and we could just convert it into a list. So at the end of this, we have a list that consists of all the peer IPs, which is what we want. We want all the peers as a list. So at this point, we have, what is our operational state? The peers. It is this list of neighbors. What did we intend? It is this list of neighbors. We then compare the two, and in this case we have it just fail if the comparison says there are any differences, and we use this symmetric difference to accomplish it. So now we validated that our peers are correct, and we actually failed in the case of PyNet Router 1. There is more validation we could do. We could verify we reached the established state for all our peers. We could remedy this peer, the one that failed on PyNet Router 1, and we could remove that other peer. And there's other verifications we could accomplish as well. We didn't do anything with the verification of, are we getting prefixes, are we getting the right number of prefixes, etc. So as you can see, the validation process is actually pretty complicated, and there's a lot of challenges in getting it created and structured properly.